Hello and welcome everyone to Altasciences High-Potency Manufacturing Solutions. So today we'd like to take a few minutes just to discuss our high-potency manufacturing solutions at Altasciences CDMO, Philadelphia. So a general overview of our facility, the services that we offer, the processes that we take, our equipment that's available for use, how we do some compound classification, and then how we manage our potent products. So in Harleysville, Pennsylvania, we have a 30,000 square foot facility. We are equipped to manufacture and handle high potent compounds. In this facility, we do have a grade C high-potency manufacturing room. It's approximately 2,000 square feet. Sean and I were one of the original designers 5 years ago.
Coming up on 5 years. And it's been, so one of the challenges right away was we needed grade C and potent. Right. So from there, obviously, engineering controls had to be put in place.
It was a really unique and fun project that we got to do, and I think we'll get into some of the airflows later on in the presentation to discuss that. But what we try to do in this area is put some cost-efficient scale-up equipment for our clients. We have all their standard registrations. We're also able to handle DEA controlled substances in this area, and then FDA food facility and Pennsylvania Department of Health. So our manufacturing services and processes, again, potent compounds, grade C manufacturing, just a higher classification of a room, multiple dosages, capabilities. In that area, we do formulation and product development for our clients. And here we try to list out some of the general capabilities that we have back in our grade C high potent area. So injectable vial film shown is a big one.
Sure.
That's pre-sterilized. We obviously manufacture pre-sterilized. It's thermally sterilized after it leaves here. We have a few clients in that space right now.
Exactly. Yeah.
We've done many projects with the gel cream. I think we've gone into tubes, jars, aluminum tubes, you name it. I think we can do it.
And then we've actually, our wet nano milling has been something that's been growing over the past few years. And that's actually one of the first products that went in there was actually nano milling suspension. And that also lends itself to high potency. You know, with a high potent drug, you're trying to actually lower the dosage as much as you can. And nano milling, and actually even the next one, the liquid fill hard shell capsules, are two technologies that lend itself to lowering the dose.
Yeah, that's a really good point. They really go hand in hand. Mm-hmm. Finished product packaging and then GMP warehouse. And then again, we do all phases of clinical, and then we have some commercial clients back there in that space also. Just to drive down a little bit further, some of the equipment that we have in that area that's available for use with potent compounds are kettles, mills, pumps, heater chillers, screens, and crimpers, pretty much your standard equipment. Again, depending on the classification of the potent compound will depend on how we actually engineer and control. So this is your pretty standard potent compound classification. We use the PVECL, so the performance-based exposure control limit. Categories 1 through 4. 1 is very low potency, obviously, and it steps up count-wise. 2 gets a little bit higher potency. 3 we start to consider as a potent product. And a lot of the P3s are new drug entities where there's just not that much knowledge about them.
Right, and that's most of our products that we deal with here are new. So until you have the toxicology data and everything else to support moving it from a different classification, it has to end up in that P3 category.
Exactly. And then with further development, sometimes those P3s get knocked down to a 3 or to a 2, which is great. Sometimes they go the other way into a 4, which we are still capable of handling. Here's just another diagram, and I'm going to go quickly to the next slide, but this shows you how it steps up in potency across the cubic meter, the weighted average.
And a lot of this is actually just based on standard practices in the industry.
Yeah, that's exactly right. And that's a good point for this slide. And we'll outsource to actually classify the compound. We won't take that upon ourselves. We'll actually go to the industry experts. They're right around the corner from us. And they'll help us. We'll send them samples, or a client will send them samples. They will do the formal classification for us. And they'll actually drive it down one step further. We'll take a look at what the engineering controls that we have currently in place at our facility. Tell us if they're sufficient, or tell us if we need to actually add some additional engineering controls.
Exactly.
And this is what we spoke of with engineering controls. So we really handle potent compounds here 3 different ways. And the first one is engineering controls, and we'll talk about this more when we look at the diagrams of the room, but that's obviously pre-construction. We figured out what type of engineering controls we need for potent compounds.
And that's going to extend, so engineering controls isn't just the room. More and more, anything that we can put in an isolator, disposable isolator, even better, we will. And you know, all types of equipment can fit in there now, and engineering controls are almost limitless. So it makes it easier to process even these higher potent compounds.
Yeah, that's a great point, because we do a few different isolators. like you said, softball that we can actually throw equipment in. And then it goes back to the wet nanomilling, the liquid fill capsules. A lot of times your routes of entry is inhalation for these potent compounds. So if you can wet that out immediately and not even solubilize it, but just get it in a suspension, it really hammers down to your routes of entry. So where the way and dispense might occur actually in the isolator, then we've either developed completely closed systems, or we've actually been able to just transfer them in a liquid form into the capsules then.
Right. So the safety classification actually can change, as you said, based on the route of entry and actually how you're handling it. So
yeah, that's great. So that covers a little bit with the process procedures. And then the final step is the cleaning validation. I'll let you talk about that.
yeah, so when you get into high potent materials, you're not just worried about the equipment, but you're actually worried about the whole area. So this, unlike our main manufacturing area where we can handle multiple products in any of the 4 manufacturing rooms at any given time, and we have obviously less cross-contamination risk there. When you're dealing with high potent, we want to make sure it's one product in the area at all. And we'll talk about the area in just a minute. But what we'll do is actually verify that at the end of that process that we're not just swabbing and releasing the equipment to be verified from being absent of the compound, but the whole area as well. Ceilings, walls, door handles, everything.
Yeah.
I think there's
floors, benches.
So that way when we've cleaned and we've verified the clean before any other product or equipment can go into that area.
And maybe it's worthwhile discussing how he came up with the cleaning limits a little bit, if you want to discuss how he came up with those, what's acceptable for carryover compared to what's not.
Yeah, so, well, I'll go back 25 years when they said 10 ppm, or if it was a high potent compound, it's 1 ppm. Now we kind of integrate using that, but we also take into account what size batch can be done in the equipment in the area, the lowest dose available for the product. There's a safety factor based on the PBCL classification. So basically it increases the risk. So you have to be 10 times lower for a 4 than you would for a 1. And all that mathematician probably would tear it apart and say statistically may not be relevant, but I think the industry has found it and accepted it. And
for sure, and it definitely errs on the more cautious side.
Sure. Right. Yeah, I mean, you're taking a sample, 4x4 sample, and extrapolating that over the whole piece of equipment to say if you found this much on a 4x4 area, that same amount was on the whole piece of equipment, and it ended up in the next batch.
Right.
That's the worst case scenario. Right. So.
And I'm thinking of some of the potent compounds that we've handled in the past. We basically said what's acceptable is none. You can't have any detected. There can be no carryover limit. Even though you did the calculation, you showed whatever, maybe we just said due to the nature of this compound, nothing's acceptable.
Correct.
So here is an overview of the layout of the room. Engineering controls are the primary method for the potent compound. So HEPA filters for air filtration and exhaust. You can see each room is HEPA filtered. Obviously, regular maintenance, annual calibration and certification of the HEPA filters. But here we talk about, it's pretty small to see the pluses. Maybe you can discuss a little bit about what those pluses actually mean.
Yeah, so one of the things I mentioned before, we were trying to have this as a grade C area and a potent area. If you're doing one or the other, the engineering controls are very clear. But when you're trying to do both, so you're worried about cross-contamination of the facility or from area to area, but also reducing any potential bioload, we had to actually design this a little different, a hybrid of the two. And if you look, kind of the PA25, PA27, and PA23, they're all traps, essentially. So going from the grade D area in PA22 to PA21, which is the grade C, and then likewise for the airlock, they actually had to be where the air flows. Right. And that was so that the potential of any potent material leaving PA21 is mitigated. Worst case scenario in a failure situation, it would end up in either the gowning, degowning, or airlock outside the facility. And then we went a step further. So we use a building monitoring system, and we have it. So if there's any loss of pressure of this area, it alarms and notifies you via email, phone calls, until response. But that way, if there was any failure, we would know right away.
Right. That was a really great description of how we designed that room to keep the grade C, which obviously has to be positive pressure, the cleanest part, as a grade C room, but then also keep the whole envelope as a negative pressure. That was a really good way to explain it. And there's magnehelic gauges to monitor the differential pressures between each room and the warehouse. But then we went one step above and put it on our building monitoring system, REIS, that instantaneously notifies us if the envelope is compromised, so we can take immediate corrective action.
The other thing that in this whole area, it's all disposable counting, whether we're using it for a coat material or not. So again, mitigating any risk. You go in the area, you change out your street clothes into disposable, and then as you go through with any room classification going from one grade to another, you're adding another layer. And then the reverse is true as you come out. So again, anything that's in that area stays in that area.
Right, that's a good point. With the procedures that we have in place then for walking out with wipe down procedures, obviously you can see there it's single traffic in and out of two different areas. So that's a really good point about disposables, Sean. I know a few products we've actually taken it essentially one step further. The outside firm may have said or that we needed to, or we just thought, you know what, let's add one more level of protection for the employees in the manner of a PAPR, a powered air purifying respirator. So essentially it's an additional bunny suit over the entire employee with positive air pressure over their mouth, over their face. Obviously that's filtered.
And you mentioned employees, and that's probably the most important thing. So we talked about protecting the facility and everything else, cleaning, purification, but really we want to protect the employees. And as such, those employees, they need to respect the products that they're working with. So we put the training in place that puts them in the standards that they need to follow and respect the product.
Yeah, that's a really good point. We do take time, methodical approach to really train the employees well. And the employees really, they're intelligent. Obviously, they understand the risk that it presents, but they're still more than happy to do the job because they understand all the steps that we've taken to protect them. So this is just one more example of a cleaning verification that we spoke about earlier. The one thing that we didn't leave out is it's the quality of control group. It's the laboratory that's actually coming in and swabbing it. And there's a good example of the swabs that they take. Sean, I think there's 38 or 42 points in that room.
For the whole entire area.
Yeah.
And that's in addition to that is the equipment that you're using. So depending on the equipment train, you may be swabbing 100 different points between the ceiling, walls, door handles, and the equipment.
Yeah. And I know some people may think that's slightly overkill, and honestly, maybe it is, but we think that's a good thing here.
Right.
And we want to thank everyone for joining us today. Here's some contact information if you'd like to get a hold of us here at Altasciences.
Take care.